Hi, this is Irv Shapiro with Make with Tech. And today we're going to talk about speeding up your 3D printer. When you first get your 3D printer, you're all excited. It does things you didn't think were possible. You can create things from models you find on the internet. You can design models yourself. You can use it for figurines, for toys, for practical items like shelf brackets or replacement parts. It's wonderful. Then you realize that it often takes many, many hours to 3D print things. And you wish you had a faster 3D printer. Well, there are a number of faster 3D printers in the market now, from newer companies like Anchormake or from old line companies like FL Sun. And these faster printers have a lot of appeal. But they use a combination of very specialized hardware and software to gain their speed. The question is, can you take an existing printer using a traditional style 3D printer, in this case a bed slinger, that means a 3D printer where the bed goes back and forth. This is an Ender 3 S1. And can you make it print as fast as an Anchormate M5C? They're both approximately $400 3D printers. This 3D Benji printed in 26 minutes. This one, using the default settings on Cura, which is a beautiful, beautiful print, printed on this Ender 3 S1 in 1 hour and 38 minutes. So today, we're going to look at things you can do from the front panel of your printer and you can do in your slicer to print faster. Then in future videos over the next few months, we're going to look at upgrades to an Ender 3 class printer, specifically this Ender 3 S1, that I can do to make it even faster. So stay tuned and let's learn something together. Here at Make with Tech, we help people learn about technology. We try to simplify it so that you don't have to have a technical background to understand it, yet provide enough depth so that if you are coming from a technical background, you'll find it useful. We do that by providing a website at makewithtech.com, a community discussion forum at forum.makewithtech.com where you can talk about technology in your projects and 3D printings with thousands of people, and a site at models.makewithtech.com where you can download customizable 3D printable models. Now, today we're going to look at speeding up this Ender 3 S1 with no changes to the hardware. Now the goal is to be able to get closer to the 26 minutes that it took to print this Benji on the Anchormate versus the 1 hour and 38 minutes it took here on the Ender 3 S1. Now, let's first talk for a minute about quality. This is a really beautiful print, and I'm actually going to show you a picture here on the screen of these two side by side. This is almost perfect. And the only way really to get a better print would be to use a smaller nozzle or to go to a resin-based 3D printer. So this is really an excellent printer. This print is almost as good, but it printed in what, a third of the time? Now there is a bit of softness on a couple of the edges on this print. So it's not perfect, but it's pretty darn good. Now we're going to see in a minute when we take and we speed up this S1 to that close to that speed, the print is not quite as good. So we're going to talk about what the parameters are that input printing. To do that, we need to understand a little bit about 3D printers. 3D printers are very simple machines. You already own one, you get this, you know this, but just as sort of a review, basically the most important part of a 3D printer might be the nozzle. It has a block of metal, that's the heating block, has a heating element in that nozzle. And the rest of the printer is all about moving this nozzle around a layer at a time, then moving it up, moving around some more, all the time extruding filament through this nozzle. And the way you move this around, you move a printer around, is with stepper motors. And these are specialized motors that sort of work like a clock. So you can move them the equivalent of 1 minute, like the second hand ticking at a time, very precisely. These stepper motors are used to move the bed back and forth on a bed slinger. That's your y-axis, side by side, to move the print head side by side. That's your x-axis, to move the print gantry up and down. That's your y-axis. Now, the problem is that you got all these moving parts. And then you even add to it the fact that you have another stepper motor that might be on the hot end if it's a direct extruder like this S1, or it might be on the frame somewhere if it's a Bowden style printer, that is also turning to feed the filament off the reel into the hot end. So you have all these stepper motors turning, really relatively fast. You have the bed slinging back and forth. You have the gantry going up and down. And what does that do? It causes vibrations. Now, if the best way to print often is to put your 3D printer on a concrete floor. You want the best quality prints? Put it on the floor. I have it on a sort of shaky desk here. So those vibrations are going to cause imperfections in your print. And so the trick to printing faster is how fast can you print before those imperfections overwhelm your print. Let's look at what those look like. This is a test model that's used by people who use a particular firmware on their 3D printer. Firmware is just the software in the board that's on your 3D printer that makes your 3D printer work. So it's no different than software on your computer. The difference is when you put software in a dedicated board that's sort of inside a machine, we call it firmware. There are two variations of firmware that are very popular today. There are many, many more. One's called Marlin. That's what you see on the majority of consumer-grade 3D printers, and a newer one called Clipper. Now, the newer one called Clipper does something interesting. In addition to using the board in your computer, it uses another computer to help doing some of the arithmetic of where we should move that nozzle, to optimize it to minimize vibrations, and to optimize it for something else. Because when you're printing fast, you need to push a lot of filament through this nozzle very quickly. So the nozzle has to be able to heat up that filament fast enough, and when you go to stop the nozzle or move it somewhere without extruding filament, you don't want it dripping filament all over. So you have to control the pressure to that nozzle very carefully. So this is all done by variations of your firmware, and we're going to look at that a bit today. To ensure that my test is as accurate as possible, and this is by far not a scientific test, I took a brand new roll of filament from Creality. This is Creality PLA. And we're going to install together a new printer definition into the current version of Cura. Okay, so let's go to the screen. And we'll see here we have a current version of Cura. This is Cura version 5.4. And I'm going to select the printer selection box and say add a printer. And we're going to add a non-Ultimaker printer and a non-networked printer. And we're going to find Creality here. And I'm going to select the Ender 3 S1 and say add. And I'm going to take all of the defaults. I'm not going to change anything. Then I'm going to take and load a benchy into the slicer. And I'll use the scroll wheel on my mouse to blow it up a bit. We can rotate it around. And I'm going to just click on Slice. So I'm taking all of the defaults. If we click here, we'll see that let's go into Expert mode. That'll make the majority of the parameters available. And so the defaults here include a 0.2 millimeter layer height, and you'll see the default speed is 60 millimeters per second. This benchy on the anchor mate was printed at 500 millimeters per second. Now, that's really an exaggeration. That's the maximum speed the print head will move. It doesn't move that fast very often. And we'll explain why in a couple minutes. So now let's reduce that and go to Slice. And you can see it'll take 1 hour and 38 minutes. Now, in fact, it took 1 hour and 45 minutes to actually print. So the slicer estimates don't always include the time to heat up the printer, which is still active time. The way I got the times is I did use the Creality Wi-Fi 2.0 box attached to this, and that allowed me to start a print from my computer and get accurate timing on the results. And the result was a really beautiful print. Now, if I want to go faster, I would think all I need to do is go to this box that says speed. And I'm going to go over here and let me move this up, maybe not to 500 millimeters per second like the anchor make, because I don't know, maybe moving too fast could break something. Not likely, but it's possible. So do these tests at your own peril, but I'm going to move this up to 250 and just say slice. And let's see what happens. Interesting. Originally it was 138 at 60 millimeters per second. It's now 124 at 250 millimeters per second. That doesn't make any sense. What's limiting the speed of this printer? Well, let's think about it. Within the firmware, that's the control software that's on this board, or a similar board. This is actually from a Prusa printer, so not the same. There are limits set to how fast we can accelerate our print head, our bed, the axes, and how quickly we can change direction. So acceleration is the time it takes to get from 0 to, let's say, 250 millimeters per second. If we try to accelerate too quickly, we're going to jerk the printer, right? That's going to cause a lot of vibrations. So there are built-in limits to keep folks that aren't familiar with all the details from either damaging their printer or creating terrible, terrible prints. That's called acceleration. Now, in addition to the time it takes to accelerate to speed, if I'm going in a particular direction and I want to change directions, how fast can I do that? How fast can I corner? And in earlier versions of the Marlin firmware, that was called jerk. And in current versions, it's actually called cornering. So how fast can I corner? Now, how do I set those? Well, they're defaults in the printer, but they're also settings in Cura. So if I go down here to speed, we'll see there's a setting called Enable Acceleration Control. You can turn that on or off. It's set to 500. Now, on the anchor mate, it's set to 5,000. Now, why is it the anchor mate can go so much faster, can accelerate so much faster? Well, the printer is specifically tuned so that the weight of the print head, the structure of the extrusions that hold it, the nature of the base, the size of the base, the weight of the base, those things are all carefully optimized. And in the case of the Ender 3S1, it's really optimized for quality and flexibility. But let's just try making this 5,000 here. And then we'll go down to enable jerk. That's cornering time. And let's just double that. Now, I'm going to go ahead and slice again, and we'll see whether this makes any difference. Now we're down from 138 to 116. Now, what else are some of the differences? Well, this print wasn't printed at a 0.2 millimeter layer height. The fewer the number of layers you have to print, the faster your print's going to go. This was printed at 0.28. And when you look at a close-up of this print, you can see that it's not as smooth as this print. So let's go over here now, and we're going to go to quality, and we're going to change it to 0.28. Now let's go ahead and slice. Now we're down to 60 minutes, 59 minutes, which is really quite a bit better. Now there's another item I can look at, minimum layer time. What does that mean? It means if there's a very small layer like the smokestack, and it's only going to take less than 10 seconds to print, pause before you go to the next layer. Why? Well, because the fans on the printer might not be fast enough to cool down the layer if you move too quickly. On this Ender 3S1, there's really one fan cooling down the print. On the Anchormate, there are two. But let's cheat and let's cut that in half. And now there's one other item I want to look at, and that's maximum resolution. And in some ways, it's a bad name. What that says is, let's say you have a circle. Well, 3D printers, in most cases when it's printing a curve, this is not always true. There is a way for 3D printers to print curves natively in the firmware, but most of the time it's printing little line segments. And if you make enough little line segments, sort of like string art, you'll end up with a curve. Well, this setting is the minimum size of one of those line segments. It's set to 1/4 of a millimeter. I'm going to move that up to 1 millimeter. That means my circles potentially won't be quite as precise, but I'll need less segments. Why is that important? Because every time you start or stop a segment, you have to accelerate. So now let's slice it. And we'll see we're down to about 45 minutes. When I printed this print, it looked pretty darn good. I would have expected it to look a lot worse. But here's what's really interesting. Cura reported that this was going to take 45 minutes. It actually took 1 hour and 24 minutes. That's not that much different than 1 hour and 45 minutes. So I would expect it to look similar. Why, if I set all these values down, if Cura is telling me it's going to print fast, is it printing no faster? That comes down to the firmware. Within the printer yourself, within the firmware, there are maximum values set in the firmware. And no matter what Cura asks for by sending a command, it's going to ignore it. So if we go here to the front panel of the Ender 3S1, it's really nice. It gives you access to these values. So I'm going to go to Control, and I'm going to go to Motion, and you can see it has a max speed. Those are 300. That's under what I requested. It also has max acceleration. That's set to 500. So if I want to go accelerate over 500 millimeters per second squared, which is how fast it can ramp up, I have to change it here. And if you go down to the next item, it's called max cornering. That used to be called jerk. It's now cornering. That's set to 5. So In fact, I need to increase them here. Now, that's not the whole story. The whole story is that their maximums the user interface will let me switch it to. So I can go from 500 to 1,000 on acceleration as an example. That's the fastest it will go. It's still double what it would have been. And so by actually doing a series of optimizations, by all of the optimizations in the slicer, and by making the changes in the front panel, I was able to get a benchy that prints in 46 minutes. Still quite a bit slower than the Anchormate, but quite a bit faster than the original. Now, this particular benchy is not as good. The printing on the back is a little bit blurry. The corners are not quite as sharp, but it's really not bad. And so if this was a functional part, let's say a shelf bracket that nobody's going to see, what I've just showed you is how to make adjustments to Cura and adjustments to your printer to cut the print time in about half. It goes almost twice as fast. To go even faster than that, we're going to have to change the firmware and potentially make upgrades to the hardware so we can push more filament through this hot end and we have better cooling. Well, folks, I hope you found this useful and I gave you some things to think about. Now, one thing to remember when you make changes to the UI, if you power your printer off and on, it's going to go back to the defaults unless you use the options in the user interface to save those settings. You can always restore to the factory defaults. So once again, I hope you learned something today. This was useful. If you did, share this video with everyone you know. Share the channel with people you know. Give me a thumbs up. Subscribe to the channel. Head over to makewithtech.com, to forum.makewithtech.com, to models.makewithtech.com to help support our channel. Have a great day, and let's continue to learn things together.